Yes, so shall we start? So today we are going to discuss about the revision about mux and demux.
Sir, I have some doubt in big practice activity question, sir.
Okay, please tell me. Can we
Uh,
start the revision and after that in the last 15-20 minutes can we take that one? Is it better?
Yes.
Sir, the audio is not clear, sir. Can you repeat it again?
I just say that in the starting we start the revision part of mux demux, and after that last 15 minutes we will take some problems if you have.
Sir, the deadline is today, sir. I have to solve. So, sir, please, can you do it first, sir? Then
Okay.
we can proceed to solve graded assignment.
Okay. Hmm. So yes, can you tell me the question?
And sir, the problem number one, sir, and two, sir. One, two.
Wait a minute. Just log in. Week 8
Yes, sir.
and activity questions.
Yes, sir. Activity question.
Okay. Network self interface with the row addressing combination with the lookup table. Source 7-bit ASCII code values, alphanumeric and special character. In binding from the ASCII value of the digit 1, 2, and so on are 3160 and 3260, and the fourth corresponding to row 1, 2, and so on. Answer the following questions from 1 to 4. Uh, the row address combination circuit of n bit n input decoder circuit. Okay, so if you see that the row address combination circuit of n bit decoder circuit used to select a appropriate 7-bit rows B0 to B6 in the lookup table. Select the size of n bit input for the decoder. So what is the size?
N equal to 3, sir. From my side, sir. But answer
Okay,
is n equal to 4.
and the row address combination of n bit decoder circuit used to select the appropriate 7-bit B0 to B6 in the lookup table. Select the size of n bit input of the decoder. Now
Actually, sir, in week 8, it's pretty difficult to tackle the questions. Uh,
Yes,
so,
sir. Uh,
because of lookup table.
yes, sir, but there are many more aspects that it is becoming pretty difficult to tackle the question. Since we are
Mhm.
not understanding how to solve it or what is the technique to solve it.
Yes,
I
and
have
the
tried.
professor also didn't try to solve any question. They only teach the theory part, and we
Yes,
have to
sir.
tackle every problem. Seems like a new, sir.
Oh,
Means I have tried whole day, but it was not getting solved only, sir.
Yeah. Only for solving the activity question, it's take more than 2 hours.
Yes, sir. Means, uh, uh, can you, sir, take what you can say, teach the week 8 sessions means if possible, like you taken the theory part of the week 6, week 7.
Yes, sir. Extra sessions are for problem solving only, sir. Some
Yes,
extra
sir.
session you can take. For,
week 8 problem solving.
yes,
Uh,
sir.
So
problem
can
plus and theory, sir, if possible.
okay, okay. So we can do that. We can take it tomorrow extra class for the
Yes,
weekend part.
yeah, it's
That
okay,
is
sir.
Yes.
better.
Timing, sir.
I just checked at what time you are available. So according to this one, I schedule one extra class.
Sir, if
Okay.
possible, sir, you can take it, sir, after 8 p.m., sir, because
Yeah, yeah.
before
No
that, sir.
problem. No problem. After eight, I will take after eight also. Okay. I am also happy with that particular timing. Okay. I think maybe from 9 to 10 we can take.
Yeah.
Uh, so
Sir,
till that I
I
prepare
think,
some
sir,
question also.
1 hour is not enough for that, sir. That
Okay.
number of
Nine
problem,
to
new
eleven we can
problem.
take. Nine
Yes,
to
sir.
11 we
Yes,
can
sir.
take. Okay.
Okay, sir.
Yeah, okay,
9 to
no
11.
problem. The main thing is that, sir, when you go through the videos, online videos and all that, this
Mm-hmm.
basic things are there: the mux, demux, input, output, and the basic logic and all that there.
Okay.
But when you go through the assignment questions and the graded assignment questions, there are some more logical, in-depth wise, and
Okay.
what approach need
Yeah.
to be applied there. So why not getting it exactly there?
Okay. So we can do one
The
thing
questions,
tomorrow I will prepare some questions related to the week 8 part also. Okay.
yeah,
So
And
first we go with the
activity
theory.
and
We first of
yeah,
activity
all
yeah.
we
and
go with
practice
the
question.
yeah,
Activity
yeah.
and
In
practice question also are in enough problems, sir, to build the concept.
yes,
And
yes,
if
yes.
possible, you can also build
It will
come
be
with the
better to
concept.
go quickly go through the theory part, basically in the beginning, 10, 15 minutes, and
Hmm.
half hour, 30 minutes,
Okay.
and the questions that practice and graded, because today's get what will be completed there.
Hmm.
So tomorrow we can discuss the grading assignment for the week 8.
Okay.
Practice questions are there. So the how we can approach the questions, and that will be the basic things behind approaching their particular questions now. It will be better to understand
Hmm.
or
And
get
sir,
Okay.
it idea.
the practice assignment question number 10 also, sir. We only learn about that concept about 4-bit BCD. Here it is asking
Hmm.
about the 5-bit BCD. I applied some my logic, but then it's wrong.
Every time we are taking the 4-bit BCD. Okay, if we are
Okay,
talking about the 5-bit BCD, so what is the meaning of 5-bit BCD? That it will be take two digit number.
You
two-digit
take
number
two
means.
higher digits, no?
Like for example, we have taken the 1 1 1 1 1. Okay, sorry,
Sir, you
no
have
one.
solved this question. Means you
Yeah,
tried to
I have
solve,
already
but
solved.
you said
Yeah,
that
yeah.
it is not
The
possible.
answer is 12 for that one. Answer is 12.
Sir, but
Okay,
it
answer.
is showing 18, sir.
Yeah, it is showing 18, but answer is 12.
Sir, how the answer it will, sir?
Okay.
I,
Hmm.
Actually, sir, you can take tomorrow. You can go through your revision, sir.
I have solved the predator and proof. If I didn't get this concept, I will take wrong answer in the graded assignment.
Okay. So basically, what will be the thing is that if we represented 29, the value to be added to 5-bit binary number if the input exceeds 29. Okay. So like we have a 30. Okay, we have a number 30. Okay. Now how we represent, or basically we are taking the number 29. Okay, so how we represent this number 29 in the decimal, sorry, binary? 16, 8, 24, sorry, 16, 8,
Yes, sir. After
26,
that, 0 1.
1 and 1. No. Uh,
Sir, 1
1,
1
1,
1
1,
0
1,
1.
1, 0, 1.
Yes,
Okay,
sir.
this is the basically binary number. If we are talking about the BCD number, so 2 represent as a 1 0, okay, and 9 represent as a 1 0 0 1. Now if we compare these two, okay, so it will be defined that how much we add in this number to become in this number. So what should I do? I just take a difference. So 1 0 1 0 0 1 and 0 1 1 1 0 1. So it become a 0 0. If I take a carry from here, so it is a 1. No, carry from here, it will be 10. It will be 10. Again carry from here, it will be the 11. Again carry from here, it will be the 10. Okay, so 10 is 2, 2 minus 1 is 1. It is a 3, 3, 2, 2 minus 1 is 1. Okay, now it is a 1, 1 minus 1 is 0, and it is a 1, 1 minus 0 minus 0 is 0. So this is the basically difference between these two. Okay,
Sir,
so the
what the logic of getting the correction part in BCD, that is for 4-bit BCD, the maximum number we can represent is 15.
9.
And
The maximum number is the BCD we can represent as a 9.
yeah, sir, for BCD part is 9, and
Yeah,
for normal, from the
it is a
normal
15. It is a
binary
15.
form, 15.
Yeah,
That's why we subtract 15 and 9, we get the correction part,
yeah,
that is
correct
6.
part. Yeah, exactly.
But here is a 5-bit, we can represent maximum number, that is 31, and we can represent 29 as a maximum part of BCD
Yeah,
in binary in BCD forms. That's
yeah.
why the same logic applied here. When we subtract 31 minus 22, 21, we get 2. But the correction part should be 2, na, sir, from the same logic that we get from the 6 as a correction part.
The 29 should be represented in the form of this one. Okay, so this is the binary representation. Sorry, this is the BCD representation. Okay, now maximum number is possible is 1, 1, 1, 1, 1. Okay, but here we show that the 29 should be, if we exceed with the 29, it will be the difference. Okay, what is the difference between that one? So if I am talking taking the concept of 29, so what is the 29 is 1, 1, 1, 0, 1. So if we take a difference between these two, we can find out what is the correction number that we add to convert into the BCD. Okay,
You, sir, you subtracted that the
like for
binary part
example,
of 21.
like for example, if we have a 10 number 10. Okay, so what is the binary representation of 10 is 1, 0, 1, 0. Okay, now what is the BCD number is that we add a 0, 1, 1, 0. Okay, so it is a 0, 0, 0, 0, and 1. Okay, and the number is 10 in BCD.
Sir, but the same logic you applied for 29, we have to subtract
Yeah,
it from the
so
real part of the
29 is what? 1, 1, 1, 0, 1. What should I add in this 29 so it becomes a 1, 0, 1, 0, 0, 1? What should I add? If I add x, so it becomes a 1, 0, 1, 0, 0, 1.
means we have to add that part. We have to represent the real part of 29 with the binary, and then we have to subtract it from the BCD part that
Yeah,
represented.
yes,
Then from the
exactly.
same logic, then why we had 6 when we get 10 in the 4-bit binary, we have to add 1, because the 10 in the BCD form is represented by that is 1 0 0 0 1, after that 4 0. Then from that logic we can subtract that real part of 10, that is 1 0 0 1 1 0 1 1, sir.
I just explain it that if, just listen, my thing is that if we represent a 10, okay, so what is the number is 1010. Okay, now if I convert this number into the BCD, so what should I do? I have to
Sir,
add,
screen is not shared. Screen is not shared, sir.
my screen is shared.
Yes, we're getting the screen.
The screen is getting,
Yes, sir.
Yes,
okay.
yes,
So,
sir, shared.
so basically we have a 101010 number. Now if I convert this number into the BCD, what should I do? I add a 0110. Okay, what is the answer of this one is 0000 and 1 is a carry. So it is the BCD representation. So if I in a binary number that is greater than 9, okay, we add a 6 to convert into the BCD. Is it clear? Yes? Any doubt?
What you did, you subtracted that 1010
Now,
with
yeah,
what you did, sir, that you subtracted 1010,
or
added 6 in
we
the
can say,
1010.
or yeah, or what we can do that is that we have a BCD number, this one. If I subtract a binary number 1010, what we are getting? Carry, borrow from here, so it become 10. Again borrow from here, it become a 10. It is a 1. Again I am taking borrow from here, so it become a 10. So 10 is 2. 2 minus 1 is 1. 0. 1. 1 minus 0 is 1. This 1. 1 minus 1 is 0. And this borrow already taken, so this one. So what we are getting, we have to add this number, add this. Okay. So if we subtract BCD number with binary number, we can get particularly number for corrections. Okay.
Okay, sir, now I got it. Means for the finding the correction part, we have to subtract the BCD part and that real part of boundary, and that number we have to add to get that number
Yeah.
in BCD.
Yes,
Okay,
exactly.
sir.
Now
Okay.
if we are taking the 29 or 30, so 30 is what? If I am taking the greater than 29, so 30. So what is the 30? Is the BCD number of 30 is 110000. If I am taking the binary number of 30 is 11110. If I subtract these two, what we are getting? We have to take a borrow. So from this one I take a borrow. Okay. From here to here, here to here, here to here, here to here. Now initially it become a 10. So 10 minus 10 is 2. 2 minus 1 is 1. Okay, it is a 1. 1 minus 1 is 0. 1 minus 1 is 0. It is a 2. 2 minus 1 is 1. This number is 0. Okay. So what we are getting? 18. Okay. If we are taking a 29 number, so 29 is what? 102 and 9 is 1001. Now if we are getting a subtract is 11101. Why? Because 29 binary number is this one, 29 BCD number is this one. Okay, if I subtract these two, we are getting a 1101. Sorry, 1100. So it is a 12. Clear?
Yes, sir.
Okay. Now in the question it is given, it is a equal or greater than. Okay. So it is a, okay, exceed 29. So for the exceed 29, we have to add 18. Exceed 29, we have to add 18. Okay. Now we start with the mux demux.
Sir,
Yeah.
can you explain question number 9 and 10? Not exact question, similar kind in week 8.
Graded assignment.
Yes, sir.
So graded assignment deadline is, I think, not completed yet.
No, similar kind, sir. I mean, not exact question.
The minimum amount of memory required to implement a 8-bit binary to BCD number conversion using the lookup table. You know about the lookup table if we are getting about the 8-bit binary number. So what is the maximum 8-bit? Okay, if we have a 8-bit
256.
size. Okay, so according to this one, you can basically create. Okay. And now second question number 10, a binary to BCD converter has a 4 inputs B and 5 output ABCD and valid. The outputs give the appropriate BCD value to the input and valid output is 1 if the input combination is a valid binary code. Okay, so basically it is a what? Binary to BCD converter. Okay, we have a 4 input B3, B2, B1 and B0 and 5 output. Okay, now what it says that output gives a appropriate BCD value to the input and the valid output is 1 if the input combination is a valid binary coded decimal. That means if you put a input as a 1001 till 1001, okay, with respect to this one you are getting a BCD value, okay, and your valid output is 1. Okay, now if the input combination is a valid binary decimal code,
Sir,
yeah,
why 1011?
because it is a binary to BCD, na. We have a binary
Binary
number we
to
have to give one. Okay, and what is the maximum possible BCD that we can represent in a one bit is one digit is 9.
yes,
Okay, what is the number of 9, and with respect to 9 what is the number of binary is 1001001.
1001. Yes,
So that's why. Okay, and
1001. Yes, okay.
what is the and if we say that if it is a greater than 9, that means 1001. If the input is 1 greater than 1001, so it shows the valid output becomes 0. Okay, so
Sir,
basically
what is
on the
meant by
basis of this,
valid output means?
valid is the one output pin. Okay, the value of valid output pin is either 1 or 0. Okay,
Okay, sir. And sir, in priority encoder, uh, if all input are 0, then what will be the output?
it is dependent on which particularly
Let us say
priority.
if 4:2 encoder is there,
Hmm.
means 4 input, 2 output.
Mm-hmm.
So if all bit are 0, then what is the y1 and y0?
You have to take the like for example all are 0,
Yes.
so the output is nothing, 0 0, or we can take the invalid condition of that one, input condition.
Okay. Sir, I mean to say, take priority as a logic 0.
Okay, so priority as a logic 0.
Yes.
Mm,
Then it should be, sir, 1 1 or
if it is a priority as a logic 0, so it becomes a 1 1.
1 1. Okay.
Okay, so we start with the mux part. So basically what is the mux? It is a multiplexer. Okay, what is the multiplexer is that it combines multiple input as single output. It combines multiple input as a single output. Like for example, I think you are aware with the router or switch in your home or basically in your office. You just go with the switch.
Yes.
I think you are aware with that one.
Yes, sir.
What is the
Yes,
basically
sir.
concept of that switch is that one input line is there,
Yeah.
okay, and on the basis of this one, if you say that it is a 1x6 switch, okay, so basically six output is possible, okay, six output is possible. So it is a part of demultiplexers. You can say it is a part of demultiplexer. But the thing between the difference between the router switch and multiplexer is that there is no select line. There is no select line. The particular signal that is coming from the back end, it will be transmitted into the all parts. It will be transmitted to the all parts. Okay. Now, if we are talking about the mux, so it will be basically opposite of that one. It will be take a multiple inputs, n number of inputs is possible, n number of input is possible, and it will be combined as a single output. And single output, the which particularly input is going to the output, it is basically a switch. Okay, it is basically a switch. Okay, electronic switch. It will be this way. Okay, and who will manage the switch? The switch will be managed by the select line. Okay, how many select lines is there? It is a log 2 of n. Log 2 of n. Now, for example, we have a 7 input line. Exactly, this multiplexer is not available. But if we say that we have a 7 input line, okay, so we know that if it is the value of n is 4, so log base to 4 is 2, and log 2 base of log 8 base of 2 is 3. What is the value of log 7 base 2 is between 2 and 3. Okay, so how many select line is required for that one? It is always a greater integer of that one. Okay, so if we say that a 7 input line is available, so how many select line is required? Always a greater than of that one, integer value. Okay, so 3 select line is required. Okay.
But we can take, sir, from our preference, no, as you said in the last class.
Not at our preference. Always the select line is a greater integer. Which
Okay.
mux we require, that is our choice. But if we choose a mux, so always the select line is the log 2 log base 2 of n input lines. Okay, and if n value is not a, like for example 2 raised to power something, so always we are consider the highest integer of that one. If we have a 6 input line, so how many select line is required? 3. If we
Means,
have a 7,
means it
yeah,
depends on the question only, no?
yeah, depends on the question. Okay, but select line is always a high greater integer.
Okay.
Okay, and one output line. Okay, now if we are talking about the equation of that one, if like for example if we are taking a 2 cross 1 mux, that means 2 input line and 1 output line, 1 select line is required. So this is the I naught I1. Okay, when value of s is 0, so lower LSB part of the input line is connected with the output. Okay, and when s is 1, so upper MSB part of the input line will be connected as the output. Okay, so when s is 0, I naught is selected as the output. When s is equal to 1, I1 is selected as the output. So what is the equation? Y is nothing but I naught, and I naught, when I naught will be select when s is 0, so s bar, plus I1 when s is 1. Okay, so on the basis of value of s, we can get what is the output. So if s is 0, so it become a y is what? I naught. and if S is 1, Y becomes I1. Clear? Similarly, if we have a 4 cross 1 mux, so 4 select line I0, I1, I2, I3. Don't be confused that either I mention a I0 or I3 here. Don't be confused with that I0 and I3. Where should I represent? Either I represent a MSB to LSB in a upper order, upper to top to bottom, or bottom to top. Okay, but always remember with the number. I3 is what? This is the MSB part, and I0 is what? It is a LSB part. Representation is what? Anyway, because the representation, if you see with the every different books, the representation is different. So don't get what is the representation. I think I should, sometimes I should represent MSB at a upper side, or sometimes I represent MSB as a lower side. So don't be confused with that one. Remember that I3, this particular 3 number, it represents that it is a greater than 0. So this is the MSB. Clear? So either I represent a I3 in this form, or I represent a I3, I0, I1, I2, and I3. Okay, and Y.
Sir, the screen got disappeared.
Oh, wait a minute. Yeah. Now it's fine. Okay, so I represent a I3, I2, I1, I0, or I0, I1, I2, I3. Anyway, remember that I3 means it is MSB and I0 is LSB. Don't be confused with that one. Similarly, S1 is and S0. What is the S1? S1 is the MSB select line and S0 is the LSB select line. Till it is not mentioned in the question. If it is not mentioned in anything in the question related to the select line, related to the input, you always consider that I3 is always MSB and I0 is LSB. Clear? Any doubt? Now the equation is what? When it is a 0, 0, so I0 is selected as the output. When it is a 0, 1, I1 is selected as the output. When it is a 1, 0, I2 is selected as the output. And when it is a 1, 1, I3 is selected as the output. Okay, so equation of Y is what? I 0, 0. So that is a S1 bar, S0 bar, and it is a I0 plus 0, 1, S1 bar, S0, I1 plus S1, S0 bar, I2 plus S1, S0, I3. This is the equation. Okay, now as per your convenience, you just put the value of I0, sorry, S1 and S0. You will get Y, which particularly output is basically which line, input line is connected with the output. So for example, if I select a 0, 1, if I select a 0, 1, so S1 is 0 and S0 is 1. So when I put as a, so S1 bar is 1, S0 bar is 0. Okay, so this term is 0. This one, when S1 is bar is 1, S0 is 1. Okay, so this particularly is I1. This term is S1 is 0 and S1 S0 bar is also 0, so it becomes a 0. Okay, when I take this one, so S1 is 0 and S0 is 1, so it becomes again a 0. So all particularly 3 will be 0, only Y is nothing but I1.
How, sir?
If I select the S1, if I select that S1 is 0 and S0 is 1.
Okay.
Okay. So all particular term will be 0, only I1 will be the y is equal to I1. Clear?
Yes. No, sir, for particular solving, we should approach from this only.
Yeah, we just put a input value. We consider any input value, and according to this one, we check what is the output.
Okay. And sir, similarly for means decoder also means I'm a bit confused in
I
decoder.
am not getting a decoder right now.
Okay.
Okay, so first we cover the mux demux. After that, we go to the decoder encoder.
But means sir, the demux is not that much in this content, no?
Okay.
So my doubt was that the decoder questions are pretty means
Demux and decoder both are useful.
okay, not usefulness, not, but in this week the demux is not that much, no. So I asked that if the decoder part is
Okay.
covered.
Okay, so we start with the decoder.
Yeah, yes, sir, if possible.
Okay, what is the meaning of decoder is that?
Just writing the Boolean expression for the decoder,
Okay.
the terms of output and how to approach it.
Okay, so basically what is decoder? First of all thing is what is a decoder? Any idea?
So it converts the binary value to decimal.
It convert binary value to
Decimal.
decimal. Decimal or any other number we can say that. Not we can consider that it is a decimal. Okay, so for example, if we are using the 3 cross 8, so we can say it is a binary to octal. Okay, if we are using a 4 raised to 16,
Sir,
yeah,
so decoder definition, what is the definition of decoder? Otherwise, we can
it
say
is
it is a
a conversion from binary to other code.
binary to
Other code.
other code.
Other code
How,
is
sir?
what? Why other code? Why I am saying the other code is that if we are talking about the 3 cross 8,
Hmm.
okay, so that means if our input is like, for example, I am just selecting the input is I2, I1, and I0, and output is Y0 to Y7. Okay, so what is the output
Yes.
we are getting? It is a octal number.
Yes. Octal number. Okay.
Why octal number? Because octal is in the octal number. I think you are aware with the binary, decimal, octal, and hexadecimal.
Right, sir.
Okay, so if we are talking about the binary octal number, so octal, what is the maximum possible value in the octal is 0 to
7.
7.
Sir. Yes.
Okay, and in the output you see that it is a 0 to 7.
Can't we say 0 to, I mean, binary to decimal, we can't say?
We can say that one be binary to decimal, but in the case of decimal, the number should be greater than 8 is also possible. But in this 3 to 8 recorder, we only represent 0 to 7. Okay,
Okay, sir, got it, sir.
what is the basically binary to octal is that octal is what 0 to 7. Okay, and decimal is what 0 to 9. So we can say octal is basically nothing but a subset of the decimal number. So if we represent a 0 to
Yes, sir.
9 and in between them I am taking 0 to 7, it is a octal number. So
Right,
octal
right,
is
sir.
nothing but a subset of the decimal number.
Yes, sir.
Okay. Now similarly, if we are using a 4 cross 16, okay, and we
Yes, sir.
select a combination in this way that it will be the maximum value is 1001 is possible. When the value is greater than 1001 or 1010, so automatically it will be reset the enable pin. So enable is 0. Okay. So now what is the combination? It is a binary to BCD. Why? Because after 9 it is a reset. When the value is greater than 9, it is reset. This particularly decoder. Okay. How can we reset? That is a different thing. But if I create a circuit, so when the value is greater than 1001, that is if the value is greater than 9, automatically the signal enable pin is 0. And when enable pin is 0, automatically my decoder is off. Okay, so basically it can't represent the value that is greater than 9. So we can say that this is the binary to BCD decoder.
Okay, sir.
Okay, if we represent a all combination, we are not resetting. If we represent a all number from 0000 to 15 1111, so it is a hexadecimal also. Okay, or the binary number also, decimal number also. So basically decoder, if we say that it is a basically the binary to decimal, but along with that the binary to decimal I can configure that is with the binary to octal, binary to BCD, any number.
Okay, sir.
Okay, so that's why I am saying that decoder is nothing but it is a conversion from binary to other code. Okay,
sir.
simplified form you can say it is a binary to decimal converter. Okay,
Okay, sir.
but along with the decimal it can represent a octal number also, it can represent a BCD number also with some other circuit. So I can just say that it convert from binary to other code.
Okay, sir.
Clear?
Got it, sir. Yes, clear, sir.
Yeah.
But,
Now what? Mhm.
sir, apart from this, sir, in extender cell library, XOR and XNOR is not a part of extender cell library.
No.
Why, sir? That is also, I mean, why it is no, sir?
Actually, basically, we are classify our gates in 3 different category. One is the basic gates. Okay, that basic
Yes.
gate is what? And, or, and not.
Yeah.
Second is the universal gate. That is an and or not.
Yes, yes.
Okay, and third one is the complementary gates. That is XOR and XNOR.
Yes, sir.
Complex gates. That is
Yes,
XOR and
sir.
XNOR.
Yes.
Okay, so basically, in place of XOR and XNOR, we prefer to implement any circuit with the basic gates or the universal gates.
So universal gate is it is also not a part of standard cell library.
No, it is a part of the standard cell library.
Okay. Actually, professor has mentioned only not and or.
These
They
are the
never
basic
mentioned.
gate. Preferably, what we to do is that if we implement a circuit, okay, so our first preference is that we can implement that circuit with the help of and, or, and not.
Okay. Yeah, that is okay. But in standard cell library, professor has written that in that no, they have mentioned that in standard cell library only not and or. So that was my doubt. Why
Basically,
it's there?
what purpose we are using, that is the different, because if
Okay,
we
sir.
implement if we use a transistor, okay, so with the help of transistor we design a gates. Okay, either basically BJT or CMOS we are using. So with the help of this one we design a gates. Okay, now the first thing is that with the help of gates, like for BJT or CMOS, we can initially design a and, nor, and not.
Okay, sir.
Okay, so that's why in this way the professor says that it is a not a part. Other gates are not a part of standard cell library. You can implement that gate with the using some particularly again a CMOS circuit, again a basically CMOS. Okay,
Okay.
but with the help of CMOS and BJT, you can initially design a not and or.
Okay, sir.
Okay, now
Yes.
if we are talking about the NAND gate, so basically NAND gate is what? It is a combination of and not.
Yes, sir.
That means you are using a two basic gates.
Yes, sir.
Okay,
Yes, sir.
that's why.
And Yes, sir. Sir, next question is in mux, in hierarchical order mux, if you want to
Can
design
I
higher order,
explain this thing first of all?
okay, sir.
After that, we'll take the question. Yeah.
Okay, sir.
So basically, the what is the decoder is that if we are giving a input 000 with respect to these input, my output line will be the 1. Okay. So if we are talking about the 000, so what is the binary number decimal number of with respect to 000? It is a 0. So that means y0 line will be 1. Okay. If we are taking a 001, so it is a binary number of 1, so y1 is 1. If we are taking a 010, it is a binary number of 2, so y2 is 1. If we are taking a 011, it is a binary number of 3, so y3 is 1. Okay. And similarly, if we are to apply the 111, so it is a binary number of 7, so y7 is 1. Okay. So this is the basically decoder. Now, in the case of decoder, two types of decoder are available. One is the active high, second is the active low. Okay, so one is the active high and second is the active low. So in this case, this is the active high. Okay, where only according to input that we apply, my output line will be the 1 and remaining will be the 0. Remaining will be the 0. Okay. Now, if we are talking about the active low, so what is the meaning of active low? With respect to I2, I1 and I0, my pin is low and rest will be the high. Y7, Y6, Y5, Y4, Y3, Y2, Y1 and Y0. If I apply a 0, 0, 0, so my Y0 is 0 and rest are 1. Because it is an active low. So how can you measure that active low? There is one bubble is there. One bubble is there. So what is the meaning of bubble? It will be invert the output. Okay, so in this particularly scenario, if it is a 0, 0, so when I take a invert of 0, it becomes a 1. When I take a invert of 1, it becomes a 0. Okay, similarly, if I am talking about the 1, 1, 1, so y7 will be the 0 and rest are the 1. Okay, if we are taking a 1, 0, 0, so y4 is 0 and rest are the 1.
Sir, for this active low decoder, can the enable also be an active low pin?
That is if it is given in the question.
Okay, so
Okay,
if the
may be
enable is
possible, yeah.
okay,
It may
so
be possible the enable is active high or active low. Okay, if we
okay,
say that enable is like, for example, this one. Okay, because different ICs there. Actually, this is the IC configuration. Okay, so design, when we are going to design a IC, there are the different logic combination is possible to design a IC. So which particularly IC is designed by which logic, on the basis of that one, it will be decided that it is an active low or active high.
sir. So if I give an if this is an active low, then I have to give 0 for enable. Then only it will
Yeah, work.
become
It
active.
will be work. Okay.
Okay.
If it is a on normal enable, if it is a normal enable, so in this case, when enable pin is 1, and when enable pin is 1, then it will be working. Okay.
Okay.
And if it is a active low enable, so when enable pin is 0, then it will be working.
Okay, sir.
Okay. And when enable pin is 1, you can given any of the input, there is always a all 1.
Okay, sir.
Okay, so it is called the invalid state. Okay, now you can use this particularly decoder for the implementation of any circuit, any Boolean expression, any mean max term, anything. Okay, like for example, if we say that we have to implement y a b c is equal to sigma m 0, 1, 4, 5, and 7. Okay, so this is our pin. If you are taking a 3 cross 8, so 3 input, 8 line 1. Okay, now you have to create a basically this one. So what is the meaning of this one is the m0 plus m1 plus m4 plus m5 plus m7. Okay, and when the m0 is coming, when it is a 0 0 0, or when it is a 0 0 0, y0 is selected. So basically at this point we are getting a m0. Okay, similarly m1 is coming from y1 pin, so it is a y0 y1. m4 is connected as 2 3 4 y4 pin. Okay, m5 is y5 pin, and m7 is a y7 pin. Okay, now all terms will be ORing. So what should I do? I use one particularly OR gate, multi-input OR gate. Multi-input OR gate and combine this one OR gate. So here you are getting m0 plus m1 plus m4 plus m5 plus m7. Now the thing is that you ask the question that 5 input OR gate is possible or not. Okay, so if it is available in the market, we can club a 5 input OR gate. If it is not available in the market, if we in the question it is given that we have to only 2 input AND gate, OR gate is available. So now what we do? Initially ORing with m0 and m1, then ORing with m4, then ORing with m5, then ORing with m7. Okay, and finally you are getting a m0 plus m1 plus m4 plus m5 plus m7. Okay.
No, sir. Means if I have three students, eight decoder, and the min terms are more than the what you can say expected output, so we will need more decoders, no, to solve it. Like if I have 30, 31, the min terms 30, 31, 28, 27, something like that.
Mm-hmm.
So
So yeah, we had required a more multiple decoders. Okay.
so means like the professor lecture, like we have to what you can say to draw that no thing like in level 1, level 2 format.
Yes, 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 yes. Like for example, we have to implement a 4 cross 16 decoder. Okay, using 3 cross 8. Okay, so we have a 3 input is available and 8 output is available. Okay, so what we required is that we have to use 8 input. So I can say it is a y0 to y7. Okay, now again I have to take a one more decoder that will be used y8 to y15. So how many output lines we have? 16. Okay, so
Yes.
16 line is completed. Now the thing is that for this particularly 8 we required a 3 input. So 1 2 3. Similarly, 1, 2, 3. So 3 lines, basically 3 input are connected. So we can say this is the one input, second input, or you can select as a this one, second input and third input. If it is a I0, I1, I2, so I0 is here, I0, I1 and I2. Okay, because I0, I1 and I2 are common. The sequence will be same.
Means we have to connect that input together, means with each other.
Yeah, if I2 pin is connected with the I2 pin, because both I2 will be common.
We will get the same output, like same midterms, Y0 means Y15
If you
in
say
the
that
order.
if you say that it is a I0, I1, I2, if it is I0, I1 and I2, so I0 will be connected with I0, I1 will be connected with the I1, and I2 will be connected with the I2. Okay. Just so I0 I just mentioned it as a D, I1 as a B, C, I0 as a B. Okay, so 3 input line is defined. Now we have to implement a 16 cross 1. We required a 4 input line. 3 is this one. Now what? We are required one more decoder. That is the 1:2. Okay, so A is this. A is this one. Now this A is connected with this enable pin, and this particularly is connected with enable pin.
Means the MSB bits are connected to the enable pins.
Yeah. Now why? How we define that? We have a 4 input A, B, C, D. Okay, so for 0, 0, 0, 0 to 0, 0, 1, 1, 1. Okay, so it is a Y0 to Y7, and 1, 0, 0, 0 to 1, 0, 1, 1, 1, 1. That means Y8 to Y15. Okay, so it's A is 0. If A is 0, this is particularly pin will be the 1. Okay, here we are getting the 1, and here we are getting a 0. Okay, now 1 is connected with the enable. So basically this decoder 3 cross 8 decoder will be enabled, and this particular decoder will be disabled. So we are getting output from Y0 to Y7. Clear?
Yes, sir. Means, the
Okay.
sequence matters here.
Yeah. Now if A is 1, that means this particular pin is 0 and this pin is 1. So when this one is 1, enable is this one enable is 1, this enable is 0. So this is the basically disable, and this one is the enable. So Y8 to Y15 output is there. Clear?
Yes, sir.
Now we go with the BCD. So my first of all, either my Y0 to Y7 is enabled, or Y8 to Y15 is enabled. So any one decoder is enabled. Now we go with the BCD. If BCD is 0, 0, 0, that means B is 0, C is 0, D is 0, Y0 is selected. If B is 1, C is 0, D is 0, Y4 is selected. Okay, 1, 0, 0, 4. Okay, if it is a 1, 1, 1, Y7 is selected. Clear?
Yes, sir.
These input will be common for all. If B, C, D is 1, 1, 1, so here also we are getting a 1, 1, 1. Y15 is also selected, Y7 is also selected. But the problem is that This is the disable. This particularly is the disable. When A is 0. When A is 0, this one is disabled, this one is enabled. So only Y7 will be go to the output. If A is 1, so this is disabled, this is enabled, so Y15 is go as output.
Is that 1:2 decoder
Yeah.
it gives the A and A bar as a output, and that A bar is
Yeah.
connected to the that first decoder.
A bar is
the-
connected with the first. Why? Because if we see that here from Y0 to Y7, A value is 0. So A bar is connected
Yeah.
with the first, okay, and A is connected with the second.
That's why
If
we
I
get
change,
0 to 7.
yeah, if I change it is a Y8 to Y15 and Y0 to Y7, then what we do? We have to change sequence. Now we have to change sequence. Now this particularly first bit will be connected with the this one, and second will be connected with this one. Okay.
Yes.
Okay, so if you design a hierarchical decoders, that means from the lower order decoder to higher order decoder, first thing is that we ensure the output. We ensure the output. Like for example, if we design a 3x8 decoder with the help of 1x2. So two input is available with each decoder, and how many how many input we required? 8. So what is the how much we required? 1, 2, 3, and 4. So two line from there, two line from there, two line from there, and two line from there. Y0, Y1, Y2, Y3, Y4, Y5, Y6, and Y7. Now can I draw a truth table also? If the input is I am taking the A, B, C. So 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0, and 1, 1, 1. Now you can see that C value 0 and 1, C value 0 and 1, C value 0 and 1, and C value and 0 and 1. So either this one or this one. So which is the input? C. Because C value Y0 when C is 0, and Y1 when C is 1, Y2 when C is 0, Y3 when C is 1. Okay. If I choose a initially B, so this is the Y0 and Y2. Why? Because for the value of B, once it is 0, once it is 1. So we have to choose these two, Y0 and Y2. Clear? If I take a Y0, Y2, Y1, Y3, Y4, Y6, and Y5, Y7. So we can take a B. Clear? Any doubt? Just any doubt why we are taking the B and why we change the sequence of the output?
Yes, I mean, when B becomes 0, the min term is M0, and when we take B as 1, it becomes the Y2.
Y2, because Y for the Y1 is B is also 0. If you see
Yeah.
the Y1 is B is also 0. But this pin is select when B is 1. Okay,
Yes.
so we check that where the B is 1, B is 1 at this particular position. So we have to take a Y2.
Yes, sir. Got it.
Okay. Now to select these particularly 4, we required a 2 1 cross 2 also. Okay, because 2 output will be given from that one and 2 output will be given from that one. And where these 2 output will be connected? Select line. Select line. Select line. I use a different color. Select. Sorry, enable line and enable line. Enable line and enable line. Okay. Now which input we required? If C is 0, first order will be select. Okay, if C is 0 first, so we are considering the C here. Now can you check when C is 0? When C is 0, so this particularly pin is enabled and this pin is enabled. Okay, when C is 0, these 2 pins are enabled. Can you check when C is 0? This one and this one will be enabled. So Y0 and Y2 will be enabled. Y4 and Y6 will be enabled when C is 0. Okay, when C is 0, first and third decoder will be enabled. And what is the output of first and third is Y0, Y2, Y4 and Y6. Now with the truth table we see that when C is 0, C0, C0, C0 and C0. So Y0, Y2, Y4 and Y6 will be enabled. Okay, and when C is 1, this one is enabled. Which one? Second and fourth. Okay, second and fourth. Any doubt? Now what is the output of when second and fourth will be selected? Y1, Y3, Y5 and 7. So when C is 1, this one, this one, this one and this one. So Y1, Y3, Y5 and Y7 will be enabled. Okay.
Yes.
Now we take a consider that when C is 0 and B is also 0. So can you tell me which one is the output line we use? What is the output line is enabled? So when C is 0, possible that Y2, Y4, Y0, Y2, Y4 and Y6 are the enabled. Okay. Now when B is 0, when B is 0, Y0 and Y4 is the enabled. When C is 0, first and third decoder will be enabled. When B is 0, first pin of the first and third will be enabled. So Y0 and Y4 will be enabled. Now can you check when B and C is 0? So when B and C is 0 is this position and when B and C is 0 this position. So Y0 and Y4 will be the possible enabled. So it is verified. Any doubt? When C is 0 and when B is 0, which particularly pin will be possibly high or possibly enabled? When C is 0, first and third decoder will be select, and when B is 0, first pin of the first and third decoder will be select. And what is the first pin of the first and third decoder is? Y0 and Y4. Now from the truth table you can see when B and C both are 0, Y0 and Y4 will be the possible solution. Okay, now we have again a two decoder, okay, and two input line. What we design? We have to design a 3x8. We have to design a 3x8. That means one more input line is remaining. Okay, one more input line is remaining, and to select these two, to enable and disable these two, we required a one more decoder. So we required a one more decoder, 1x2. I use with different line, different color. So basically this is enabled with this particularly, and this one would be enabled with this one, and the input is A. Now verify when A is 1, B is 1, and C is 0. Which is the output line? Which one is the output line? When A is 1, can I draw with different color? When A is 1, this line is selected. This is enabled. Okay. If this is enabled, then C is 0. So when C is 0, so this line will be enabled. Okay. Now when B is 1, when B is 1, this line will be enabled. And the line number is Y6. If you know 110 is nothing but a decimal number of 6. So Y6 will be enabled. So that means your hierarchical structure is now correct. Any question? Any questions or any doubt? Yes. Any questions or any doubt? So I think we stop here. Now it is a clear that how a decoder will be work.
Yes, sir.
Okay. Yes. Now anyone want to ask the question, they can ask. Yes. One.